Right, this video we're going to talk about modelling linear growth and decay. So linear growth or decay occurs when quantity increases, that's growth, or decreases, that's decay, by the same amount at regular intervals. So, whether this is yearly or monthly or weekly, it's that regular intervals, the same time schedule, and it's always by the same amount. It either increases or decreases, grows or decays by the same amount every time. Okay, so simple interest or depreciation are examples of this. Now we'll talk more about these things, but I want to make sure that you understand what interest is. We talk a lot about interest. I think about interest as the cost of borrowing or lending out money. So you think about borrowing money. That's when you've gone to the bank for a personal loan or a credit card. We mostly talk about loans in further maths. And you get charged interest for what you owe them. So that's the cost of borrowing money. And when you put your money into a bank account, you earn interest, don't you? So when you borrow money, you incur interest. But when you put your money into a bank or you invest, you earn interest. Now, why do you earn interest? I've just said interest is the cost of borrowing money. You earn interest when you are investing in a bank account or something, because that bank is borrowing the money from you. So you've put the money into your bank account. They can take the money from all the bank accounts and lend it out to other people for their home loans or other things. They need to give it back to you, but they do with interest. So that's why when you have a bank account, that's an investment, you earn interest because the bank is borrowing money from you. So I think of interest as that cost of borrowing or lending money. But that's what interest is. Now here, when we're talking about linear growth, we're just talking simple interest. Simple interest. Now, you would have done a fair amount of simple interest in general maths and in other maths over the years. So this is, in further maths, we talk about having it as a model. So a recurrence model for linear growth or decay. So here is a model of a rule, where D is a constant. D is unchanging. So here I've got my example where my initial amount was 20 and that D was 6. So you can see it's going up by 6 each period. Okay, it's going up by exactly the same amount each time. And that's what linear growth is, isn't it? When we've looked at linear graphs, it's always going up or going down by the same amount each and every time. So that's linear growth. So linear decay is when the amounts reduce. So you can see here, with my example, I've started, my initial amount was 35. And I'm going down by 4 each time, going down with that negative. Now, this decay, the P might be representing the value of an asset. So this might be talking about depreciation. Depreciation is thinking about an asset, so a car, a photocopy machine. These are assets that you might have, and they go down in cost, or down in value over time, I should say. So you think about a car. 5 years after you've bought the car, it's not worth the same amount as what you've paid for it. Now, there's different ways of calculating what that new value would be, but it's all called depreciation, and we're going to discuss several ways of calculating that. When we're talking about linear decay, we're talking about flat rate depreciation or unit cost depreciation. So that's where it's going down by the same amount each year, or unit cost is talking about, like with a photocopier, it might go down for every 100 things you've photocopied. Or the car, you might be talking about, well, for every kilometre, you lose so many cents worth of value. So it's going down by the same amount each time. So simple interest and loans and investments, and flat rate and unit cost depreciation. When we see those words, we must be thinking linear growth or decay. So let's focus on the simple interest loans and investments for the moment. So interest is the fee for borrowing money, that cost of borrowing money, as I was talking about before. Simple interest, a fixed amount of interest paid at regular time intervals. Principal, the amount borrowed or invested, the initial amount, the starting amount. So these are some words you must be familiar with and must be comfortable in using. So make sure you have them in your glossary. So simple interest is a case of linear growth. It goes up and down by the same amount each and every year or period. Okay, it does not change. So it's the same at each iteration, at each time period, as the interest charged is based on the principal at the start of the investment. Okay. The interest charged is based on the principal at the start of the investment. So we calculate an interest on that principal, and then that's the interest that we always charge. So R is the percentage interest rate. D is the interest charged at each time period. VN is the value of the loan or investment after N years. So V0 is the initial amount, the principal, and we can write this out, the rule out.
Okay, I found this on the web for is the initial amount principal. Check it out.
Sorry, Siri just interrupted. So D is the interest that is getting charged each period, or the interest that is incurred each period. And you can see there that it wouldn't change each time. So we can calculate D by doing that percentage of the initial amount. So let's go through a worked example. $325 is invested in a simple interest account for 5 years at 3% per annum. So PA is per annum, and that means per year. Set up a recurrence relation to find the value of the investment after N years. So we have to have a recurrence relation that's general enough to find it after N years. So my R is 3%. So 3% of 325 is $9.75. So my recurrence relation is V0 equals 325, comma, Vn plus 1 equals to Vn plus 975. So part B, using that recurrence relation, find the value of the investment at the end of each of the first 5 years. So we can see here there's my initial amount. There's, after 1 year, I've got $334. So then I add $975 to get the end of 2 years, 3 years, 4 years, 5 years. So I've set it out by hand here, but I'm sure you can envisage how you do that on your calculator. Okay, depreciation. So over time, the value of an asset reduces or depreciates. So when it's gone down to a certain point, when it has depreciated to a certain point, we call that a scrap value. So your company may have decided that when a certain asset, like say a car, has depreciated to only being worth $10,000, it's going to get rid of it. It's going to scrap it. So that's what scrap value is. It might sell it or take it to a wreckers or something like that. So we need to be able to predict this future value of the asset, and the linear model of decay can be used. So flat rate depreciation. So in the similar to simple interest, we have that constant amount is used each time period to decrease the value. Okay, so flat rate depreciation has that constant amount, the depreciation amount, subtracted to decrease the value of the asset. So you can see here the recurrence relation looks very similar. Looks very similar to the simple interest one. So we've just taken V0 as the initial value of the asset, and now we're minusing because the value of the asset is decreasing. So that's flat rate depreciation. Similar to that is unit cost depreciation. So it just depends how you choose to depreciate the value of something. So a computer or other electronics like that, you might decide it decreases by the same amount each year in value. Whereas a car or a photocopier, you might decide, well, the more kilometres a car is driven is not going to be worth the same as a car that's been driven less. So this is where we might employ unit cost depreciation. So here looks the same, but D is the cost per unit of use. So you can imagine that D is for every 100 kilometres it loses so much of its value for a car. So let's look at a couple of examples here. A mining company has bought a vehicle for $25,000 and chose to depreciate it by the flat rate method. The depreciation was 15% of the cost price each year. So find the annual depreciation. So 15% of 25,000 is 3,750, and because it's flat rate, it's going to be that amount every year. So set up a recurrence relation to represent the depreciation. So we do that. Our initial amount is $25,000, and our rule is Vn plus 1 equals Vn take away 3,750. What is the value of the vehicle after 3 years? So you can see I've popped that into my CAS for you and done that. So after 1 year, 2 years, 3 years, the value of the vehicle was $13,750. It's gone down by the same amount each year. Now that's using that flat rate method. Now there's not a lot of exam questions I could find just on this. It usually goes a step further. So make sure you're doing the questions out of the book and asking any questions.